Welcome back to the DevOps presentation series. This is Satyadev. In the last presentation, I was talking about DevOps phases, and as a first phase, I talked about code. In that code phase, we talked about several things that involves code phase, which is like developers, unit testing, code review, developer machines, sandbox machine, all those stuff we talked about in the last presentation. In this presentation of DevOps phases, I'm going to talk about build phase of the DevOps phases. So as I told you in previously, CAC in the CI/CD DevOps process, there are 5 stages: develop, code, build, test, deploy, and then monitor. So these are all the several phases. So we are going through each and every one, right? So we already covered code. We are seeing the build phase now. Let's go to the next slide, the build phase. Now, the build stage involves following 4 main components. They work together in the same sequence for the build activities to complete. Now, I already talked about what are build activities, right? So, basically at the end of the build, we should have an installer. So, the build should compile the code, get the code, compile the code, provide, make all the components, make sure that all the components are there, create an installer, and then put it in a place where everybody can access, get the installer and install. That's pretty much what the build process. So like that, there are 4 steps. The first step is the first component is the revision control system, which we already talked when it comes to development, right? So all the developers will put the code into the RCS, revision control system. The build server, the server actually builds the code. The artifact repository where the installers or whatever artifacts are going to be installed, we kept. The package manager. It's like a addendum kind of thing, like for the build server, but I'll talk about that as the last item. So these are the 4. Let's look into these 4 items. Now, the revision control system. Now, the revision control system, RCS, is the component where multiple developers store, retrieve, and update the code collaboratively. So yeah, I already created a series on Git repository. If you look at that if you look at that presentation, you will understand what is Git, what is RCS, and all that stuff. So you know how Git works and all that stuff. So basically, it's used for collaboratively coding, storing code and retrieving the code and updating the code. Multiple people, they could be sitting next to each other, or they could be sitting geographically separated regions at all. One in US, one in Canada, one in UK, and one in India. They could collaborate without any problem. So there is one Git repository, a centralized repository. So that's what RCS is, revision control system. Git is basically a distributed centralized RCS. This component is not only used to store the code files. So again, this is not just to store code files like Java, CS, or Python, C++, JS, or SQL, etc. So I use it for store other non-auto-generated files such as configuration files. It doesn't just store code only. JSON files, configuration files, YAML files, YML files, initial configuration files, INF files, which are used in Java mostly. XML files like CSS, cascading style sheets, or whatever. So all these things which are like part of the needed for part of build process, they will also be there in the repository. Documentation files, script files, project metadata files, test files, design files, etc. They also will be there in the vision control systems. So basically, one blind rule or one rule of thumb is that anything that is required for build or has to be shipped as part of the build, they should be in the revision control system, which will be changing. However, things that will be generated from the build, for example, DLLs or .o files or intermediate files, TMP files, email, those kind of files should not be into the repository, the version control system or the revision control system, because each time they will automatically generate it, right? We don't want to put it. Even EXEs also is not recommended to, DLLs recommended to put, but they should be, the installer has to be done because that's the one piece that used for installing, right? So it should be okay. Not all the other binaries files which are like automatic generated should not be put. But image files that are used part of the project, yes, they have to be there in the RCS. So basically that's what it is. Like script files like means shell files, bat files, PS files, etc. Project files means like make files, POM files. They have to be there because they require for the build to happen, right? And these are written manually. So test files like .txt, Java, JS files, UML diagrams. Again UML diagrams, fig files and text files. They are basically they support the release, right? So how the architecture is. These are again drawn by human beings or some web. These are not going to change every time. They are not automatically generated, right? So they are drawn or they are for one-time thing kind of thing. So yes, they have to be there. Um, Development team chooses RCS system. Normally, it is the development team. They choose what kind of RCS system they want. Like if they want to use Git, they could use a GitHub or GitLab. Local Git can be installed, but distributed Git, what is the centralized Git distributed? What is it you want to use? GitHub or GitLab? Or there are other things also, like or you want to use a CVN or SVN, VSS, TFS. There are several options, but nowadays I think everybody is going towards Git, right? So Git is what being used in most of the places. That suits to their need, and they also decide on the directory structure of the code organization. So basically, they want to decide on how the code. Most of the time, the directory structure represents the organization in which they work. It's actually very good. It's a law, basically. For example, let's say I'm writing a price calculation application, something like that. So you provide an item and the quantity. I'm giving the total price of it. Now I'm in price department, right? So calculation department or price calculation department. Then it should be like my company name dot the development dot price calculation, PRC cal, something like that. So it's like wherever the application is there, it actually represents the physical organization of the company. So that actually I'm going to talk about in coming presentation. There is a law that talks about it, Canvas law. So I'm going to talk about that in the later. These days, many teams are picking Git as their revision control system, which I already talked. Detailed discussion on Git will be dealt in another separate presentation script. So as I told you, I already created another presentation for Git. Have a look at the presentation to understand more about Git. So yeah, the next thing we are going to see is the build server. Now the first thing is the revision control system. First component. Second component is the build server. The build server is the component that takes code from the revision control system and builds it on a trigger. Now what happens? For example, all the developers have checked in their code. Now, then they label it. That's a trigger. But in some companies, whenever somebody checks in the code, that itself is a trigger. That means for each developer check-in, there is a trigger that happens. So it depends upon the company. Now, basically, the build server works on the trigger at the revision control system. Revision control system has the code. Now, whenever a code check-in happens, there could be a trigger. Or whenever there is something that happens in the revision control system, we define a trigger. Now, based on the trigger, the build server would act. The trigger could be a specific time frame, like every midnight. It could be a time based also, like at 12 o'clock in the midnight, a trigger happens in the build server, like in the repository. Okay, I'm ready. The code is ready. Like that, something will be then build server gets activated. Or it could be an event like after every code check-in, or whenever there is a label on the code, something like that, right? When such a trigger happens, the build server copies the code from the revision control system. So we have to configure the build servers, from where to configure, which to configure. Once we configure and we hook the trigger to the build server, because that hook is very important, right? From revision server to build server, we have to have a hook, right? That hook is like whenever somebody checks in the code, start the build process. So I checked in the code, then it triggers it. Then build server goes and get all the code, puts it locally. And then start building based on whatever it is. After successful build, the build output, for example, exes, jars, yars, wars, zips, etc., are also known as build artifacts, may quickly be tested for the sanity. So basically, you know, before even put it into put it into somewhere for testing, some sanity checks will happen. Like at a high level, quickly, is everything working as like expected at a high level, not like deep testing, like high level testing. So that's what sanity testing is. So is it really sane build or not? Does it have all the components in that kind of thing? So the whole process of building code is called continuous integration. This is again, like I told you in the previous presentation, this is part of continuous integration. There are several build servers that are available in the market, like Jenkins, GitHub, GitHub CI/CD, GitHub Actions, Bamboo, Azure DevOps Pipeline, etc., etc. There are so many things are available in the market, and this presentation assumes Jenkins has the build server for all purposes. Detailed discussions of Jenkins would be dealt in another separate presentation, which I haven't started yet. So I will be doing the presentation in another series. So presentation series. So basically, build server is what that. So basically, it builds all the output components like exes and jars and stuff like that. Next thing is artifact repository. The artifact repository is the component that stores the deliverables, artifacts from the build server. Now, before going into the artifact server, the build components are actually will be Dockerized or installerized. So they become an installer kind of thing. Then they become available to the artifact server. So once the build process is done, it copies that final installer or Docker file or whatever it is, right, into a server called the artifact server. The artifact server acts as the source of truth used in deployment pipeline and usually accessible over HTTP and HTTPS. Why? Why it is needs to be? Because anybody should. HTTPS is like a public web server, right? Anybody can secure web server. Anybody can get into that. If you want to our customers to get to the software, you should be able to do it. Build server, no. But artifact server, yes. But artifact server doesn't contain code or DLLs or EX. It contains only the installer or by Docker files or what ISO files or whatever that is required for installation. It will be there, right? So normally artifacts repositories do provide features like storing metadata such as build version, build label, timestamp, etc., about the build details, right? Timestamp based indexing, does the time based indexing. So you will see builds in a particular order, like yesterday, 10 days ago, then 9 days ago, 8 days ago, like that you keep seeing the builds. The top one is the latest build kind of thing. That's how you can see, right? So timestamp based indexing, search capable. I want to search some build, you type the build might have an extension like 24, 20, 25, 21, 6, whatever it is, right? So you search on that, you should be able to find that build. So sometimes you need older builds, right? So you want to check something, is it working? You will be able to search that build. So they provide the search capability as well. Normally a build server is different from the most of the time you have because it's HTTPS focused, right? So the artifact server is different, build server is different. However, there are certain servers they act as build server as the artifact server. This is a different variants. So so in another variant is they build servers, they put these artifacts into a separate places like into S3, something like that, Amazon S3, like data stores like Amazon S3 bucket or something like that. So there are many artifact repositories available in software market like JFrog, Nexus OS, Sonatype, Nexus OSS, GitHub package, Apache, Archiva, etc., etc. So there are so many artifact servers. So we could use any one of those artifact server. For the presentations series, Nexus, Sonatype Nexus is assumed to be the artifact server, but detailed discussion of Nexus would be outside the topic of discussion. So as of now, there are no plans for doing any presentation on build servers because it's not really part of the curriculum. But at the same time, possible, if any discussion needs to happen, we assume that Nexus is the build server artifact server that we are using. So that's about the artifact server. Now, the package manager, this is the last piece of the build, but again it's part of the build server. The package manager is the component that automates the process of installing, updating, configuring and removing software packages for a computer's operating system or a specific programming language. These package managers keep the OS PL libraries to desired version, ensuring that all components work together seamlessly. Now, this is very, very important. Basically, this build servers could be used for multiple purposes, right? So somebody might build something that uses a different package. Before actually building a particular product, it may have to get some particular versions of the software. Make sure that those versions are going to be there, not any other versions, right? In that case, we use the package manager. There are two types of package managers. Package managers that basically in package managers, what we do is we have a configuration file. In that we specify we want this product of this version, we want this DLL of this version, we want this jar file of this version. So like that we specify those things in that. Then we run the package manager. That package manager will go to the particular sites, get them download them and use them for the building purposes. So basically there are two types of package managers. One is for building getting the packages for the OS. Second one is for the programming language. OS package managers, there are several things are there. RPM, Red Hat package manager, Danified Yum. Basically in order to update the operating system with the latest one, use Yum. For Fedora or Red Hat, Chocolatey and VJEC for Windows, Homebrew for Mac OS. I mean, these are all the package managers for updating the for particular operating system, Windows or Mac OS or Red Hat or Linux or whatever it is, right? So programming managers also have package managers like Maven, Gradle for Java, pip for Python, npm for JavaScript, Cargo for REST. So these are all the package managers for particular programming language. So you say Cargo install or whatever it is, it will take care of installing everything, the right binaries and stuff like that. Similarly, Maven build. If you say build Maven or build Maven build, so it just go through all the files, get all the things that are configured in the Maven file. So detailed discussions are going to be dealt in another separate presentation series. I will have a presentation series to talk about these small kind of things. Maven would be discussed there. Right now there is no presentation available. I'm planning to do that in the future. I think that's pretty much it is. So thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.